Hi friends, once again welcome back in our educational channel, that is Precise Electronics. Friends, in previous video lecture we had studied concept of energy, conservation of energy, that is law of conservation of energy, and the Einstein's equation, that is E is equal to mc square. And friends, in today's video lecture we are going to study power. First of all, energy. What is energy? The capacity of that system, capacity of physical system to perform the work, or ability of that system to do work, that is energy. And what is power? Power is the rate at which work is performed. The rate at which that work is performed by that system is known as power. Or energy is converted. That means the rate at which the energy is converted from one form to another form. That is known as power. Electric power. What is electric power? The rate at which electrical energy is transferred by the circuit or by the system, by the device. That is power. What is electric power? The rate at which electrical energy is transferred by the circuit. For example, suppose if we switch on the bulb, LEDs or bulb, then electric energy is converted to light energy. Suppose in case of fans, when we are going to switch on the fan, the electric energy is converted to kinetic energy. So the rate at which that electric energy is transferred or converted by the circuit is known as work. Now, the measurement of power. The power is measured in watt. So obviously the SI unit of power is watt. That is honor of scientist James Watt. And that watt is nothing but 1 joule per second. 1 joule. Joule, that is unit of energy. And rate, that means a time, that is measured in second. So power, that is watt, is equal to 1 joule per second. So how 1 watt is defined? So 1 watt is defined as the energy consumption rate of 1 joule per second. What is 1 watt? It is defined as the energy consumption rate of 1 joule per second. Means within 1 second, how much joule is consumed, that is power. The 1 watt is defined as the rate, the energy consumption rate of 1 joule per second. So 1 watt is equal to 1 joule per second. 1 joule per second. 1 watt is also defined as the current flow of 1 ampere. The current flows through that system of 1 ampere with a voltage of 1 volt. That means if 1 volt supply is applied to that system, and if the current flows through that system is of 1 ampere, then the power consumption of that device or power dissipated of the device is 1 watt. So 1 watt is also defined as the current flow of 1 ampere with a voltage of 1 volt. So obviously 1 watt is equal to 1 volt, that is 1 V, into 1 ampere, that is 1 A. There is a formula to find out the power, that is V into A, product of voltage and current, and 1 watt is equal to 1 volt into 1 ampere. In DC circuit, in DC means a direct current, in DC and a low frequency AC, alternating current. AC means alternating current and DC means direct current. Alternating current, the polarity get reversed, but in DC current, the polarity remains same. The current will not change its direction. In AC, current changes direction with every half cycle. So in DC and low frequency AC, electrical circuits and the system, electrical circuits or electrical systems, power is product of current and voltage. What is power? It is a product of current and voltage. So P is equal to V into I. V, that is voltage. I, that is current flowing through that system. Power is also defined as, it is also proportional to the ratio of square of the voltage to the resistance. Ratio of square of the voltage, that means V square upon R, or it is a E square upon R. So it is a ratio of square of the voltage applied to the system and the resistance of that system. It is a ratio. No, sorry. It is also product of resistance and a square of current. The current flowing through that system, the square of that current, that is the I square, and a resistance. The product of that square of current and the resistance also gives the power. So it also gives the power. Suppose we consider a circuit. Suppose there is one circuit. In that circuit, the current, voltage and resistance are constants. All three factors are constant. The potential applied to the circuit is constant. Current flowing through the system, that is also constant, and the resistance of that system is also constant. So all three parameters, that is a voltage, current and resistance, if all three parameters are constant, then if the current is measured in ampere, if current in amperes and it is represented by capital letter I, the voltage, or it is also known as the potential difference, that is measured in volts and it is represented by, or it is symbolized by V or E, capital V or capital E, and the resistance, which is measured in ohms, and it is symbolized or represented by R, capital R. I, capital I represents the current, capital E or capital V, that represents the potential difference or voltage, and capital R represents the resistance of that system. Then these equations, the following equations, there are three equations. These three equations holds or gives the power which is in watts. Power is measured in watts. So the power is given by these following equations. The first equation, P, that is power, is equal to E into I. E, voltage, I, current, so it is a product of voltage and current. The second equation, that is P is equal to E square by R. E, once again it is a voltage, the square of voltage applied to the system and the resistance of the system. The third equation, that is P is equal to I square R. The third equation is P is equal to I square R. I, that is the current flowing through the system, and R, that is the resistance. So all three equations gives a power of that system. Friends, now one figure is going to display on your screen. From this figure, by using this figure, we can find out the power, voltage, resistance as well as the current of electrical system. Voltage, from this diagram it is clear that the diagram of that picture is now going to display on your screen. The voltage is given by I into R, or it is P upon R, or it is square root of P into R. Resistance, next factor is resistance. Resistance is given by V upon I, or it is P upon I square, or it is V square by P. So these formulas are used to find out the resistance of the system, that is V upon I, Ohm's law. We are using the Ohm's law, so that R is equal to V upon I, R is equal to P upon I square, or I is equal to V square upon, R is equal to V square upon P. Now, how the current is calculated? How the current flowing through that system is calculated or find out? So I is equal to, once again by using Ohm's law, it is V upon R. Then I is equal to P upon V. I is equal to square root of P upon R. So these three formulas gives the current flowing through the system. And the last factor, that is power. So power is given by, it is R into I square, resistance into square of current. It is given by I into V, or it is also given by V square by R. So this figure is useful to find out the voltage, resistance, current and the power of electric system. Now we are moving toward the Joule's law. Joule's law. What is Joule's law? The Joule's law states that the rate at which heat is produced when the current passes through the system, obviously the electrons flow and the heat will produced. That means when a power is consumed or when the energy is utilized or when the any work is performed, obviously the temperature of the system increases. So the rate at which heat is produced by a steady current flowing through that system is a constant steady current in any part of an electric system is jointly proportional to the resistance and the square of current. What is the Joule's law? The rate, that means a time, the rate at which heat is produced by a steady current in any part of circuit, current flowing through the circuit through any part of circuit is jointly proportional to the resistance and the square of current. So obviously Q or W, that is work, is equal to I square RT. Q is equal to I square RT. Joules, that is J. Current, that is ampere, so it is A square. Resistance I square RT, so resistance, that is ohm, and T, that is a time or that is a rate, is measured in second. So therefore Q or W, that is heat generated, is equal to I square RT. I, that is the current, R, it is a resistance, and T, it is a time. So friend, that is Joule's law. What is Joule's law? The Joule's law states that the rate at which the heat is produced by a steady current by a system when a steady current in any part of electric circuit is jointly proportional to the resistance and square of current flowing through that system. So that is Joule's law. So friends, thanks for watching this video lecture. In next video lecture, we are going to solve the numericals of temperature effect on resistance, then numericals of power, energy, kilowatt hours. So in next lecture, we are going to solve the numericals. So friends, thanks for watching this video lecture. Keep watching this video lecture. Bye. Take care. See you again in next video lecture. Bye.